This video is sponsored by Edukaji. For more free SPM video, log on to Edukaji site. The link is in the description below. Hi guys, my name is Terry. In this video, I'm going to go through the SPM actual paper for year 2024 and for additional mathematics, and this is paper 1. Okay, so let's get started with question number 1. So this is from the chapter, from 4 chapter 6 linear law. You're given a straight line a straight line graph that is obtained when y equals 4x squared minus 5 is reduced to linear form. So we are supposed to express big X and big Y in terms of X and Y. So let's begin by dividing everything by X squared. Now, I know you may be thinking, how come? Why I know how to divide by X squared? You can see a Y-intercept is 4. From this equation, you can see the coefficient of X squared is 4. In order for us to convert to linear form, to get y equals mx plus c, your c must be a number, no x, no y, right? To get rid of that, we have to divide by x squared. So let me just do it here. Divide by x squared. You will get y over x squared equals to 4 minus 5 over x squared. Your 5 also you have to divide by x squared. Now, maybe we rearrange it, as in we put negative 5 in front, split your negative 5 with 1 over x squared, and put the plus 4 at the back. Now, from here, you can see this is your big Y. This will be your gradient. This will be your big X, and this will be your C. Okay, so remember, we are expressing big X and big Y in terms of X and Y. From here, you can see that your big X, your capital X, is 1 over x squared, and your capital Y is y over x squared. That's all for 2 marks. Okay, let's move on to question number 2. This is from Form 4, Chapter 1, function. Okay, diagram 2 shows a relation between 2 sets. State the range. Remember, domain is your element, or the element in the first set. Range is, codomain is all the element in the second set. Range is the element in the second set that has a corresponding object. So you notice that 20 doesn't have an object. So it's not part of your range, right? Remember, we call this individual element as image. So it's a set of all images put together. So what is your range here? My range is, let's start with negative 5, followed by 10, followed by 15, followed by 25, and please put the braces to represent the a set of all images. Yeah, pretty easy. Now, let's move on to part B. Function gx is 3 minus x is expressed in a form of ordered pairs. Find the value p. Okay, so gx is given as 3 minus x. So we know the relation between them is this. If you put x inside, your outcome should be 3 minus x, meaning if you put, let's look at p here, you can either use the first one or second one, up to you. So for example, if I use the first one, if I put 4, I would get p minus 10. So let us substitute 4 inside your x. 3 minus 4 equals p minus 10. This is negative 9 equals p minus 10. Bring it over. P, wait, did I make a mistake here? P minus 10. Okay, I made a silly mistake here. 3 minus 4 is negative 1. Bring it over. 10 minus 1, p is 9. Now, alternately, you can also put p inside your x, and your outcome is negative 6. Meaning, you substitute p inside your x here. 3 minus p equals to negative 6. Bring the negative p to the right. Bring the negative 6 to the left. P is 3 plus 6. What is 3 plus 6? Answer is 9. Okay. Okay, so let's continue with question number 3. So this is from the chapter, from 4, chapter 8, vectors. Diagram 3 shows A and CD on square grid. Express CD in terms of A. Okay, just look at the diagram. Yeah, ask yourself, 1A is how many diagonal? This is consider 1, 2, right? 2 diagonal. Yeah. So CD will be what? Because this is 1, some more, 2.5, isn't it? So you can just write your answer. Don't have to do any form of working. So when we say express CD in terms of A, you can say that CD is what? This is 1A, correct? This is another A. This will be half A. You can just write this as 2.5 or 5 over 2A. Now, next we're going to draw negative 4A in the diagram. Remember, 1A is a 2 by 2. 4A should be 8 by 8. So let's see whether I can fit everything inside or not. This is 1A, 2A, 3A, 4A. So this is 4A. Okay. But it's in going in the opposite direction because this is negative, negative 4A. So draw the arrow in opposite direction and label this as negative 4A. Make sure you have 8 boxes, 8 horizontal, 8 vertical, right? There you go. That's your part A. Right? Let's move on to part B. Yeah. Okay, part B. This question is a bit unique because in many years in SPM they never combine other chapter except for differentiation and integration. But here they combine part A vector with part B coordinate geometry. This is coordinate geometry, and the question also mentioned solution by scale drawing or vector are not accepted. That means you have to use coordinate geometry method. And actually we are using what ratio formula here, the nx1. Let me write down for you. nx1 mx2 over m plus n, ny1 my2 m plus n. So this formula is given in exam. Okay, I know how to use this because they gave us a ratio, and you're finding coordinate point C. They say C lies on AB such that AC AB is 2:1. Okay, AC AB is 2:1. So guys, there's a mistake here. It's ACCB. ACCB is 2:1. So that means C should be a point in between. C should be perhaps here, C, right? So this is 2, this is 1. So we know we have to use this formula. Maybe I write it here. Coordinate point C will be, when you use this formula, remember, the most important thing is that your M and the N, right, when you multiply, you need to multiply with the opposite coordinate. For example, your N, you need to multiply with x1, y1. Your M, you must multiply with opposite here, x2, y2. Yeah, you don't even have to label, just multiply across. So let's begin by taking 2, multiply with -1, plus 1, multiply with 5, total ratio 1 plus 2. Okay, then you continue with the second coordinate, the y coordinate, 2, still -1, right? Your b is still -1, the y coordinate, m is 1 multiplied by 8, total ratio 1 plus 2. So please make sure you write 1 by 1. You cannot just write 3, have to write the whole addition, 1 plus 2. So this is 5 minus 3, minus 2, which is 3. 3 divided by 3 gives us 1. 8 minus 2, which is 6. 6 divided by 3, answer is 2. So the coordinate point C is just 1, 2. Okay, moving on to part C. This one is nothing to do with the earlier one, nothing to do with this, right? They say solution using scale drawing not accepted, so you use equation straight line. Given a point P, 4, 5, and Q to 1 lies on Cartesian plane, find the equation straight line which is perpendicular straight line PQ passing through P. Okay, you can do a sketch, don't draw exactly. Let's say P is here, 4, 5. Q is here, 2, 1. You want a straight line perpendicular to PQ passing through P, right? So number 1, let's find out the gradient of PQ. 5 minus 1 over 4 minus 2, that gives us 3 over 2. Now PQ is perpendicular to the second line. You're finding equation of second line, right? We use the formula M1 times M2 equals to -1 because they're perpendicular, right? So your M2 is -2 over 3. And remember, to form equation straight line, we use y minus y1, mx minus x1. Your y1 is this Your x1, y1 is at point P. So it's 5. Your gradient is negative 2 over 3. Your x1 is 4. Okay? All right. Did I make a mistake here? Okay, sorry. I made a mistake here. 4 over 2. Yeah, sorry. I just realized that. The gradient is wrong. This is 4. 4 over 2, which is 2. So this is 2. You divide it, negative 1 over 2. Right? Your gradient is negative half. So let's multiply inside negative 1 over 2x plus 4 divided by 2. Can we write 2 straight away? Yeah. And then you plus 5. Bring the 5 over to the right hand side. Your y is negative half x plus 7. Yeah, there you go. That's your equation of straight line. Okay, the next question, we are going to derive the formula for length of arc S equals R theta. Actually, this is quite easy. It's a very easy derivation. But you got to remember your Form 2, your Form 2 maths, you learned this before. That is, we call it arc length or length of arc. If you divide by your circumference, right? Circumference. Arc length is AB. Circumference is 1 whole turn. So the ratio must equal to angle subtended at the center, theta, divide by 360. You want, I can write the whole thing for you. We call it angle subtended at the center of your circle, divide 360. So your arc length, we use the symbol S. Circumference, we use 2 pi r. Now, if angle theta is in degree, then we use theta over 360. But if your angle theta is in radian, we use theta over 2 pi radian. This is still in degree. This one we convert to radian. Remember, 180 degree is 1 pi radian. 360 degree is 2 pi radian. Now, we can cancel the 2 pi and 2 pi, right? Okay, or maybe I write one extra step for you. I write S equals to 2 pi r times theta over 2 pi. Cancel them. Your S is therefore equals to r theta. Right? It's pretty short. You don't really have to do a lot of working. Do you really need to write this? No need. We can straight away write starting from here. Right? Starting from here, work towards your answer. You get your S equals to r theta. Okay, question number 5, this one involving logarithm, and you have to change the base of the logarithm. So how do I know? Now you look at the equation here. This is m, the base is m over n, whereas these bases are m and n. So they have different bases. So we need to express this in terms of x and y. So we're going to convert to base m and base n. So the first thing we need to do is this. You notice that we don't know whether we should convert to base m or base n first. So what we can do, guys, I'm going to write this over here, log base m over n p, right? We can use 1 over log base p m over n. Okay, let me just say this again. There are 2 versions for formula to convert or change a base. The first one is you change the base c. B stays on top, A stays down. The second version is this. If you change to base B, right? What happened is this. This is base BB. This is base BA. Log BB is just 1. So I can just write this as 1 over log base BA. You notice this one? This is base AB, base BA. So we can just change it this way. Swap the position of the base and the number. Now, then only I start to split them. Now, I know how to split them because this is base MP, this is base NP, right? Whereas I have a P here, this is base M, base PM. Remember logarithm, divide, you break it up, becomes a minus log base PN, right? Now, only then I change the base one more time. Again, I'm going to use this formula, 1 over log base NP minus 1 over log base NP, right? And notice I can use this result now, the information that I have here, this one, x and y, I can take this and sub inside. So the next line will be 1 over x minus 1 over y. And we can combine this as a single fraction. Take 1 times y, which is y, x times negative 1, negative x, divide by xy. Lastly, I'm going to invert it. Yeah, 1 over 2 over 3, you invert becomes 3 over 2. So likewise, when you invert this, you will get xy over y minus x. Okay, question number 6. This is from Form 4, Chapter 3, System of Equation. All right, you're supposed to solve this simultaneous equation using the method of substitution or elimination. So it's up to you, whichever method. Some people like substitution, some people like elimination. Personally, I like elimination. Yeah, I like elimination when you're given all three terms. It's easier to eliminate. Yeah, substitution is going to be a bit longer. But you can also use a mixed method, like part of it use substitution, part of it use elimination, right? Okay, so let me just copy out the equation down first. Minus 4x minus 5y minus 6z equals to 4. Okay, hopefully everything is okay. Huh? So, yeah. Okay, so let's begin by identifying which variable to get rid of. So you can decide by looking at this. This LCM 2, 3, 4. LCM is 12, right? So the second one, your LCM 3, 1, 5. The LCM is 15, is bigger. The third one is also 2, 4, 6. The LCM is also 12. But the way I look at it, between x and z, right? Z is actually easier to eliminate. Why? You see, if you take equation 1, the 2 you just times 2, you get 4. 2 you times 3, you get 6. So you can eliminate easier. If you eliminate x, the 2 here you have to times 3, the 3 here you have to times 2. So there's a lot more work to be done, right? So that's why I decided to eliminate z, not x. But up to you. Again, this question is kind of open. There are many ways to solve it, right? So let me begin by taking equation 1 times 2. 2x times 2 is 4x. 3y times 2 is 6y. 2z times 2 is 4z. Negative 6 times 2, negative 12. Call this equation 4. Now I need you guys to focus on equation 2 and equation 4 and decide, should I plus or minus? In this case, we plus, right? Because you want to get rid of z. Yeah? So take equation 2 plus equation 4. Minus 3x plus 4x is a single x. Y plus 6y is 7y. Minus 4z plus negative 4z plus negative 4z becomes 0. And minus 7 plus minus 12 minus 19. Call this equation 5. Okay. So remember, our goal is to reduce it to a simpler linear equation. Instead of having 3 unknown, we want to reduce it to 2 unknown. Okay. So I've eliminated z from equation 1 and 2, but I need to eliminate z from equation 1 and 3 as well. So you can see there's a 2, there's a 6. So your equation 1, now you have to multiply by 3. So 6x plus 9y minus 6z equals negative 18. Call this equation 6. Now you want to focus on equation 3 and equation 6 now. Focus on this equation. So instead of adding, now we have to subtract. Because your negative 6z or negative 6z, you're going to multiply it. You're going to subtract with negative 6z to cancel them out. Maybe I take equation 6 minus equation 3. 6x minus 4x is 10x. 9y minus 5y becomes 14y. The minus 6z plus 6z minus become plus, cancel out. Minus 18 minus 4 minus 22. All right, so I've eliminated my z. I think we can divide by 2, make the equation smaller, easier, simpler term. 5x plus 7y is now negative 11. Call this equation 7. And now we focus on equation 5 and equation 7. We should subtract, yeah? Take equation 7 minus equation 5 so that I can get rid of y. The 7y minus 7y disappear. 5x minus 1x is 4x. Minus 11 minus 19. Wait. minus 11 minus 19. That's plus 19, right? So it's minus 11 plus 19. So it's going to give us 8. So your x is 8 divided by 4. X is just 2. So once you got the value of x, you find your value of y. We sub inside any equation. I take equation 1. Your x is 2. Your y is now, you got to bring this over, 2 over, minus 19 minus 2 is minus 21. 21 divided by 7. Your y is negative 3. There is a negative in front. Then we sub inside equation number, which equation? Actually, any equation, but maybe we take equation 1. I know my x is 2. I know my y is negative 3. I need to find my z. So minus 2z here equals negative 6. So this is 4 minus 9, negative 5 minus 2z equals negative 6. Bring it over, 2z equals to negative 1. Z is 1 over 2. The negative will cancel each other. Your answer is just half. Okay. Question number 7. This is from Form 4 Chapter 5 progression. So it is given that the first three terms of a sequence are 4, 8, and 16. We're supposed to state the type of sequence, give a reason. So it's either arithmetic or geometric. So remember, if it's arithmetic progression, your T2 minus T1 must equals T3 minus T2, right? So you actually don't have to do that. You can see it's obviously not, right? Because your 8 minus 4 is going to give us 4. And your 16, right, minus 8 is going to give us 8. Obviously, they're not the same. Yeah, so it's definitely not arithmetic. So we got to do geometric progression. So how do you test whether it's geometric? We take T2 divided by T1. Yeah, so take T2 divided by T1. Second term is 8. First term is 4. You get 2. Then take the third term, divide by the second term, 16 divided by 8. You will get 2 as well. Now, since T2 divided by T1, this is the same value as T3 over T2. Yeah, you can call this R1, R2 if you like. So we can conclude that this is a geometric progression. So the reason is because your T2 divided T1 is the same as T3 over T2. Okay, they are both 2. All right, this is only the first part. Then they say, find the nth term of the sequence. Remember, for geometric progression, your Tn is given by ARn minus 1. Yeah, the nth term. We know our first term. My first term is 4, right? My first term A is 4. My common ratio I know is 2, right? From what we have done here. So the nth term will be ARn minus 1. Okay, actually you can simplify further. So I shouldn't stop here because 4 is 2 power 2. There's a 2 power n minus 1 here. You can put the bracket inside, outside, doesn't matter. So when you multiply, remember indices, when you multiply the number, we add the power. So this is 2 power 2 plus n minus 1. Answer 2 to the power of n plus 1. Yeah. So, yep, we can leave it like this. Yep. Okay. By the way, you can also write your answer as 2 power n times 2 or 2 times 2 power n. Okay, maybe I write like this. Yeah, it's also okay. It's not an issue if you write 2 times 2 power n. Okay. All right, moving on to the second part. Part B. In an arithmetic progression, the second term is 5p minus 10. The 10th term is 7 times the first term. So here we form two equations. The second term is 5p minus 10. The 10th term is 7 times the first term. Okay, we know our first term is A, right? First term A. Your formula will be for Tn will be A plus n minus 1d equals 5p minus 10. Now, here's the thing. You have an equation with 3 unknown, A, D, P. But I don't want D because they say express A in terms of P. So I need to give you a D. So let's make D as a subject. This will be 5 b minus a minus 10. Call this equation 1. For my second equation, Tn is what? A plus n minus 1d equals to 7. First term, a. We can bring the a to the right-hand side. This should be 9d equals to 6a. Maybe I can make d as subject, or we can just sub d from equation 1 inside equation 2 directly. Okay, before we substitute, notice 9 and 6 we can also simplify, right? 9 and 6 you can divide by 3. You get 3d equals to 2a. Call this equation number 2, right? Now let us sub equation 1 inside equation 2. So don't write d, write 5b minus a minus 10 equals to a. Expand the bracket, 15p minus 3a minus 30 equals to 2a. Bring your a to the right-hand side. 15p minus 30 is now 5a. To find a in terms of p, I basically just divide everything by 5. As I divide by 5, 15 divided by 5 is 3. 10, 30 divided by 5 is 10. Right. Sorry, 30 divided by 5 is 6. So my answer is 3p minus 6. Okay? Okay, moving on to part C here. A polygon with n sides is drawn such that the sides of interior angle form a geometric progression, arithmetic progression. Is given the size of the largest interior angle is 5 times the smallest interior angle. Remember, the formula for interior angle of polygon is given by the sum of the first n term is given by n minus 2 times 180. Right? If you want to find the individual interior angle, you need to divide by n. Right? Okay. So here they say the smallest. Okay, can we add together? We need to form a equation here. We know the total interior angle for they say the largest is 5 times the smallest. So we know the largest, we know the smallest, so we can use this formula. Let me write down here, n over 2 a plus l. Remember this? Remember sum of first n term of arithmetic? Now we know it's arithmetic. Why? Because, for example, they already mentioned here, it forms arithmetic. The angle keep increasing until the largest one is 5 times the smallest one. So let's use this formula directly. I know my n over 2 bracket, my first term is a, my largest is 5 times the smallest. The result is n minus 2 times 180. So what are we finding? We're finding a in terms of n, right? So we're almost there because we just have to rearrange the equation. Maybe what we can do is we put this together. This is 6a, n over 2. We can cancel them, right? Or should I? Okay, I just write one extra step times 180. So 6 and 2 cancel, left with 3, right? You can write 3 and a if you like. N minus 2 times 180. 180 you can divide by 3, right? What is 180 divided by 3? 60. Okay. Well, we can stop here. You can, if you want it to look nicer, right? You put the 60 outside. Even if you expand or don't expand, it's okay. So you can leave your answer like this, right? Or you can expand the bracket. So when I say expand the bracket means you can put a equals to, for example, 60 n over n minus 120 over n, and simplify further, 60 minus 120 over n. Yeah. Okay. But it's okay. You can actually stop here. Don't need to do any further. Trigonometry. Okay. Number 1. Question number 8 from 5 chapter 6 trigonometry. You're given sine A is b over 2 and sine A plus b minus sine A minus b is 2p. Express the following in terms of p. So let's begin by drawing a triangle, because when you're given sine A is p over 2, right? I think we can just read from the triangle here. Let me draw a triangle like this. They say A and B are acute angles, so we know it's in this direction. Sine is the opposite over hypotenuse. To find the adjacent, right, we just take 2 square minus b square, put the square root over you get square root of 4 minus b squared. I'm using Pythagoras theorem here, 4 minus b squared. Now, if you want to find cos angle A, just read directly from here. Is your adjacent. This is your adjacent. Adjacent is square root of 4 minus b squared. Divide by your hypotenuse. Hypotenuse is just 2. Okay, first part is still okay. Now, the second one, we're going to use addition formula. Let me list out the formula. Addition formula for sine is sine A plus minus B. When you expand is sine A cos B plus minus cos A sine B. So sub inside, let's expand this. Inside the first formula, let me write here sine A cos B plus cos A sine B minus, put a bracket. This time, the second one is a minus. For sine, plus you expand is still plus. You see this? If this is plus, this is plus. If it is minus, your expansion is also minus. So this is sine A cos B minus cos A cos B. The result is 2b. Now, you can substitute inside first, but for me, I'll just subtract first. Okay, let me do slowly, step by step. This is sine A cos B plus cos A sine B. Multiply the negative inside, sine A cos B minus minus becomes plus cos A cos. Wait, I wrote this wrongly. This is cosine, sine. Sine cos, cosine. So the second one is a sine. Let me just change it. So cos A sine B, the result is 2p. Okay, now next we can cancel these two. Yeah, and add the other two. So once you add up, you get 2 cos A sine B. The result is 2p. Cos A, if I read from here, is square root of 4 minus b squared. Sine B is what we are finding. We're finding sine B. Notice that? So we just have to divide them. My sine B is therefore 2p divided by 2 is just a single p. Divide by square root 4 minus b squared. Yeah? A bit interesting, right? This question? Yeah? A bit different from what you have been doing all this while. Okay, sorry, the cos A here, I forgot to divide by 2. There's a 2 in the cos A here. See that? Your cos A from the first part, there's a 2 over 2 here that I missed it out. So as you cancel them, you can cancel these two. Just divide by square root 4 minus b squared. There is still a 2 in front here. So your sine B is 2p over square root 4 minus b squared. Okay, next one, let's move on to question number 9. This is from differentiation from 5 chapter 2. So diagram 6 shows a rectangle ABCD. At the instant, value of x changes from 3 to 3 plus p, such that p is a small value, right? Using differentiation expressed in terms of p, the small change of area of ABCD at that instant. Okay, so let's first form the equation for area of rectangle. Your length and breadth, you can put length is 5x minus 1, breadth is 2x, expanded is 10x squared minus 2x. Now, remember, you have to use differentiation here. The small change that the question also mentioned here, using differentiation. So let's differentiate dA dx. That gives us 20x. 10 times 2 is 20, 20x. Reduce the power by 1. Differentiate negative 2x. You get minus 2. Okay, now you're finding the changes when your x is 3. So substitute 3 inside. My dA dx will be 20 times 3, 60. 60 minus 2, 58. Right? Remember this formula, delta A over delta x is approximately dA dx when your delta x is small. The question already says delta x is p. P is small. Maybe I write down for you. Delta x we can find by taking the final value minus the initial value. The initial value is 3. The difference is p. So to help you understand better, just do a quick sketch of this graph. So this graph maybe looks like this. I just do a sketch with R. Let's say it looks like this. at the point where x equals to 3, the gradient of this line is your dA dx. The gradient is 58. Very sharp. Huh? Okay, this x and a. So now it increases from 3 to 3 plus p. My delta x is p. I want to find my delta y. I want to find what happens, what is the increment in my y value. So we're going to use this formula here, right? Not delta y, delta a, this is a. Delta a divide delta x, which is p. The result is the same as your dA dx, which is 58. So when you multiply over, your delta a is 58p. Okay, moving on to part B. So we have diagram 7 here that shows two lot of land, P and Q. Both lots will be planted completely with the same type of grass. Okay, I zoom up a bit because I need more space to write. Okay, oops, sorry, one more time. Now, given that perimeter of lot P is 54, area of lot Q is A. Using differentiation, find the value of y such that A is maximum. So your A is this area. We're going to use area of trapezium. Okay, so let's begin. Roman 1. Formula for area of trapezium is half sum of parallel side. Your parallel side is 3y and 5y add together. Your height of your trapezium is 38 minus 8y. So this is 8, right? 8y, if you times half, that gives us 4y, 38 minus 8y. You multiply inside. Yeah, you can use your calculator. 38 times 4, that is 152y. 4 times 8, 32y square. Right? Now, next, what we need to do is to differentiate. We need to differentiate A, dA, dy, because you need to find the value y such that A is maximum, right? To do so, when you differentiate this, you get 152, the y disappear. 32 times 2, that gives us 64y. Now, remember, minimum maximum happens when your dA, dy, in this case, dA, dy, not dy, dx, it's 0. So let us take this, equate it to 0. 64y is now 152. Let us take 152, divide 64. Answer is 19 over 8. You can leave it as fraction, or you can change to decimal. So if you change to decimal, it will be 2.375. Okay, let me write this. Or 2.375. Okay, that's the value y. All right. Now, actually, you don't have to, show that it's maximum because the question didn't ask us to show. But if you want to double check, right, you can differentiate dA, dy. Take your dA, dy here, differentiate one more time. You get your second order differentiation. We call it d2a dy square. That is, when I differentiate 152, I get 0. Differentiate negative 64, y, I get negative 64. This is less than 0, meaning A has a maximum value when your y is 19 over 8 or 2.375. Yeah, okay, actually, like I said, don't need to do that. It's not necessary to do this unless the question says show that it has a maximum value. Okay, now, hence, determine the lot that will be planted with the most grass. Justify your answer. The question already said that the perimeter of lot P is 54. So we need to find out what is your x value by adding all this together, equate it to 54, and then calculate the area of P, then compare with the area of Q. So let's look at P. Your perimeter will be 2x plus 2 of x minus 1. The result is 54. Because I have 2 of this, and I have 2 of this. So add them together, that's your perimeter. Maybe we divide by 2. X plus x minus 1 is 27. 2x is now 28. X is 14. If you know the value of x is 14, you can find area of P. We take the length, which is, should I write the length first? The length should be 14. The width is 14 minus 1, x and x minus 1. So it's basically 14 times 13, 14 times 13, 182. Okay, but I haven't found the area of Q yet. We know Q has a maximum area, but I haven't calculated area of Q. So we take your y, which is 19 over 8, substitute back inside your a here. This is your a area of Q, the first part. So we take 152 times 19 over 8 minus 32 times 19 over 8 square. Okay, so let's count. For me, I'll type 19 over 8, press equal, save it in my calculator, right? When you press equal, it will save as an answer. Every time you press answer equals, it will come out to be the same value. So take 152 times answer minus 32 times answer square. You should get 361 over 2. Okay, 361 over 2 is a bit hard to see, so I'll change to decimal. Is 180.5. Yeah, maybe right here, 180.5. So which one will have most grass planted? Answer is what? Lot P. Yeah, yeah. Lot P will have most grass planted. Why? Because you can say the area is bigger. You can see area is because its area is larger, right? At 182 cm. Is cm actually is meter square. Sorry, I've been writing cm. This is meter. Yeah. Or should I say is large is okay, should I say because its area is the area is 1.5. If you take 182 minus 180.5, you get 1.5, right? 1.5 square meter larger than lot Q. Maybe I should write that. Yeah, take the difference out. 182 minus 180.5 is 1.5. Okay, question number 10. This is from Form 5, Chapter 3, integration. So when you differentiate this function, you get gx. If you integrate gx, you get back the original function. What is your original function here? 1 over x squared plus 1 plus c. But there's a 3 in front here. So you need to multiply everybody by 3. So this will be, or should I just use the result? Yeah, just take it out. That means I start from here. Starting from here, we will take out the 3, gx dx plus 1 integration of 1 dx. Yeah. So when you integrate gx dx, you will get 1 over x squared plus 1. When you integrate 1, you get x plus c. Just put them together. 3 over x squared plus 1 plus x plus c. Okay, that's all. Yeah. Wait. Let's do this first. Now, let's look at question number 9. Question part B. Diagram shows the shaded region. The shaded region is 9 over 2 units, and integration 0 to h fy equals to k to m fy, which is 3 over 2. So what is this actually? Now, when you integrate fy dy, is this area 0 to h fy dy. This area is 3 over 2. This k to m is also 3 over 2, right? Now, the one on the left, we don't know. We do not know what's the area, right? So can we add them together? We know that the total area is 9 over 2. So maybe I write 3 over 2 plus integration of h to k fy dy. Now, but be careful. This area, right, cannot be negative. So normally what we do is we can get a negative value when you integrate, but the area cannot be negative. Normally what we do, we modulus it, right? And then you add this part here on the right hand side, 3 over 2. Your total area is 9 over 2. So to find this, right, okay, you can write this as 9 minus 3 minus 3, which is 3 at 3 over 2, right? Okay, but you can put a modulus if you want. Don't put modulus also, never mind, but you always remember the final answer is negative. Why is it negative? Why is it negative? Because this is on the left hand side. when it's on the left-hand side, right, when you integrate, your x value is negative. So when you integrate x dy, your x value is negative. The result of integration is always negative. So that's why your answer for Roman 1, for this part is negative 3 over 2. Okay, we haven't finished yet. This is just to calculate this area. But if you want to find integration for 0 to k, okay, let me confirm. 0 to k means we are taking from here to here. So there are two parts. 0 to k of fy dy is actually 0 to h fy dy plus h to k fy dy. Yeah, these two add together, the first part plus the second part. Now, so happen they have the same area. The first one is 3 over 2. Second one is negative 3 over 2. Your answer is 0. Yeah. Okay. Remember, why do I modulus this? Okay. For me, actually, I prefer not to put modulus. Actually, yeah. As in, why do I put a modulus here? Because this area is negative. It's on the, this integration is negative. We modulus to make it positive, right? So, or you can, another way is to put a negative in front straight away. We know this area is negative. Sorry, the integration is negative, area is positive. You add a negative in front, then you take the negative, you transfer over. You can do that as well, right? Maybe it's better you do it that way. But anyway, since I've written here, I'll just keep the modulus over here. I just keep the modulus here, plus modulus. And when you open a modulus by right, I should put a plus minus right. But here we only take negative. Why? Because this is on the left. And when you integrate from 0 to k, we are taking 0 to h, 0 to h to k. I hope you know what? 0 to h plus h to k. These two parts add together. The part 0 to h is positive 3 over 2. The part h to k is negative because it's on the left-hand side. Your total answer is 0. Okay, haven't finished yet. We still got the second part. Okay, the second part we are finding integration of h to k plus k to m with a 5 over 4 in front. Just have to substitute inside. Let me move up. I don't have enough space. I have to move up. Okay, let me start from here. Your x value of h to k. Where's h to k? h to k. We are actually finding this part. Isn't it? H to k is on the left hand side, right? So it's negative 3 over 2. This one, the 5 over 4, we can take out. K to m fy dy. Your k to m fy dy is the same, right? They are all 3 over 2. This part here, maybe I use a different color. This part here is also 3 over 2, right? Okay, so we just add them together. Negative 3 over 2 plus 5 over 4 times 3 over 2, right? We can use our calculator. Actually, I would factorize and cancel them, but it's okay. You use a calculator, right? This will be negative 3 over 2, right? You plus 5 over 4 times 3 over 2, you get 3 over 8. Yeah? All right. Okay, question number 11. This is from permutation and combination from 5, chapter 4. So there are n plus 1 points on the circumference of a circle. Each point is connected by a straight line to all other points. There are 4n straight lines that are formed. Okay, so a polygon can be formed by connecting on the circumference of a circle. Find the total number of polygons possible. Okay, so first of all, you have a number of points. We don't know how many points are, but when we join together, right? Any 2 points you join together, you form a straight line. Yeah, whichever 2 points are you want to join. The question is, how many straight line, right? When you take n plus 1, you choose any 2 points. There are 4n straight line that you can form. Remember, straight line, we only need 2 points. So, and the formula for NCR, if it's given in the exam, is n factorial, n minus r factorial, r factorial. So here we're going to write n plus 1 factorial, n plus 1 minus your r is 2, factorial 2 factorial equals to 4n. So let's simplify for the n plus 1 factorial, divide n minus 1 factorial with the 2 factorial. The 2 factorial is just 2. Can I multiply over? Maybe the next time I times over. This one is still 4n. Okay, how do you cancel this? You remember 5 factorial is 5 times 4 times 3 factorial. We can write this. If you want to simplify 5 factorial and 3 factorial, right, you just divide by 3 factorial. We can cancel them, right? So likewise, I'm going to change this to n plus 1, followed by n minus 1 factorial over n minus 1 factorial. Whereas the 2 I times over to the right-hand side, I get 8n. Reason why I do this is because I want to cancel this too. N plus 1 factorial with n plus 1 factorial, right? And we can expand this. This is n squared plus n equals 8n. Bring your 8n to the left-hand side, you get 7n. We can factorize this, and you have two answers for n, either 0 or 7. But obviously, your n cannot be 0. Yeah, number of points. There are n plus 1 points, so it cannot be 0, right? Yeah, then you get 0 line, right? So n is more than 0, so we take n equals to 7. But we're not done yet. The question asks for how many polygons you can form. So if your n is 7, right, that means your total how many points are? Your number of points is what? Your points will be 7 plus 1, they are 8 points. They are 8 points, right? There are 8 points on the circumference of the circle. The question is, how many points do you need to form a polygon? Minimum is what? Minimum 3. 3-sided, 3 points will form a triangle, right? You can have 4 points as well. It forms a quadrilateral, right? You can go all the way until 8, but this one very long. There are a lot of points to consider. They are, wait. So your total number of points, right, guys? Number of ways would be, since you're 8 points, right? Okay, so 8, I choose any 3, or I can choose any 4, or I can choose any 5, any 6, 7, or 8. Yeah, very long. This is very long. 3, 4, 5, 6, 7, 8, right? So let's count. So use your calculator. This will be 8, choose 3, 8, choose 4, 8, choose 5, 8, choose 6, 8, choose 7, 8, choose all 8. Yeah, wait, 8, choose all 8. Your answer is 219. Yeah, 219. Okay, so here we have a dormer. Let me just explain. A dormitory consists of 5 bunk beds. Each bunk bed has a top bed and a bottom bed. Table 1 shows the weight of 10 boys to be placed in the dormitory. Student A, B are twins, right? Okay. I think, right, guys, let me just confirm. Hang on. Okay, I think there's a typing error here. This is supposed to be 48. Yeah, this value is supposed to be 48. Okay, so here you have 5 bunk bed. Each one is top bottom. The weight of 10 boys are given. A and B are twins. So find number of ways to arrange them if there's no condition. So you got 10 different bed and 10 different boys. So how many ways can we arrange them? Answer is just 10 factorial. Now, it doesn't matter whether the bunk bed is on top or below, because the bunk bed looks like this. Let me just draw 1, 2, 3, 4. Okay, I shouldn't draw like this because they're together. It's like this. This is bunk bed 1, bunk bed 2, bunk bed 3, 4, 5. So if there's no condition, the first one, how many options? You got 10 options. Next one is 9. Next one is 8, 7, 6, 5, 4, 3, 2, 1. So it's basically 10 factorial. Just use your calculator, 10 factorial, very big number. You should get 3628800. 3628800. All right. Now, next they say student with weight more than 50 kg are placed on the bottom, and the twins are placed in the same bunk bed. Okay, so this one is very interesting. Student with weight more than 50, how many of them is more than 50. Maybe I put, sorry, I'm going to use H as heavy. Heavy are those more than 50. More than 50. How many students more than 50? Can you count for me? Student what? Student B. Who else? Student E. Right? Student G. And student H. There are 4 students. So how many of them are, maybe I call it L's for light, light, up to you, whatever you want to use it. Light means less than 50. You have student A, student C, student D, student F, student I, student J, right? So there are 4 here, and you have 6 here. So now, remember, the heavier one below, the lighter one on top. And the student A and B are twins. So for the twins, who is heavier? B is heavier, right? So you need to put B below A on top. But the problem is, where can I assign them? So number one, you got to think where to assign the twins first. How many ways can I put the twins? Okay, picture this. Let's say I call this bed number 1, bed number 2, bed number 3, bed number 4, bed number 5. The twins, I can put in any one of the bed. Do you realize that? So there are 5 P1 ways to arrange the twins. Correct? I need to arrange the twins first. I can put the bed number 1, number 2, number 3, number 4, like there are 5 ways. So we put the twins first. Then let's put the heavy one. Now let's say the twins are, the twins occupy here and here. The twins, there's no other way to arrange them. You cannot put A below. You have to put B below. For example, the twin for the heavier twin is B, right? I put below, A on top. I fix the position. There's no other way to arrange them really. But I still have to arrange who's the heavy one? E, G, H. The 3 other heavier boys, I have to put them. I can only put them where? I can only put them here. 1, 2, 3, 4. There are 4 P3 ways to arrange the 3H. I call it 3H, H for heavy, sorry. Yeah, hope don't offend anybody. Right? Now, next, how many, after you arrange the 4, let's say you arrange the heavy one here. 1 here, 2 here, let's say the 3 here. Now you notice, you only arrange 3, right? There are only 3 more heavier one. And you got how many more empty spaces available? You got 1, 2, 3, 4, 5 more empty spaces available. Right? Isn't it 5? Okay, now, because you already put A already, you put the heavy one all taken already, you still got 5 other people that you haven't arranged, the lighter one. Including one lighter one has to sleep below here. So how many ways to arrange the rest? You can write 5p5, you can write 5 factorial. I'm just going to use 5 factorial. So it looks like this, 5p1, which is 5, times 4p3, right? Then you times 5 factorial. There you go. My answer is 1440. 14400. Okay, this one is the remaining 5. Remaining 5L. L is the light one. Okay. Okay, question number 12. This is actually from Form 5, Chapter 5, probability distribution. Okay, so here we have a diagram that shows 6 letter card used in the binomial experiment. A card will be chosen randomly from the experiment, right? From each binomial trials, then it's replaced. That means you choose a card, total the number or the letter, and then you put it back, then you choose again, right? That's a Bernoulli experiment, right? This is replaced. So there are 120 trials. Find the expected value of number of consonant letters that will be chosen. Remember, expected value in other words is mean, and mean is given as NP. So here what's your P? P is the probability of getting consonant letter. Consonant is what? Consonant will be, guys, your consonants are C, R, D, K. So these are consonant. So the probability of getting consonant is 4/6, which is 203. This is your small p. Your n is what? Your n is 120. This is your small p, the probability of getting consonant. Your n is number of trials. So your expected value or mean is 120 times 2 over 3, answer is 80. Right? Expected value is 80. That means if you draw 120 times, right? You draw it, put back, you draw it, put back. On average, you get 80 consonant cards. Now, next, if there are 5 trials, the number of consonant letters chosen is more than number of vowels. Okay, consonant more than vowels. Okay, maybe you can think of it this way. When you draw 5 cards, consonant more than vowel. In what situation 5 cards consonant more than vowel? You can have 3 and 2, 4 and 1, some more, 5 and 0. Even 5 and 0 we can still consider. Yeah, it's still more than vowels, right? So here we're going to use the binomial formula px equals to 3, 4, 5. For 3, remember the formula is n, c, r. R is 3. Your p is probability of getting consonant, 2 over 3, power 3. Your q will be not getting consonant, 1 over 3. Remember, p plus q is always 1. If your p is 2 over 3, your q is 1 minus 2 over 3, which is 1 over 3. You got to use n minus r. Yeah. Then continue with 5c4, 2 over 3 power 4, 1 over 3 power 5 minus 4. Followed by 5c5, 2 over 3 power 5, 1 over 3 power 5 minus 5. Now all these you can type in your calculator manually, or you can use your calculator function. I know some are using the class quiz, right? The class quiz can also do that using the function, but I'm going to show you using this calculator. I'm going to use this shift sum, the log, right? I type the general formula 5, shift C is your C, shift divide is your C, X I have to use alpha close bracket, multiply 2 over 3 close bracket power alpha X followed by 1 over 3 power alpha is 5 minus alpha x, like this. So you start with 3, you end at 5, you press equals. I got 64 over 81. Okay, 64 over 81. Let me check. Can we use our calculator to double check? 7901, right? Yeah, 64 over 81 or 0.7901. You can leave it in decimal, you can leave a fraction, doesn't matter. Yeah. Okay, question number 13, this is from the chapter vector. So from 4 chapter 8. So diagram shows points P, Q, and R on a Cartesian plane. So find PQ in terms of H. Okay, so PQ in terms of H. Remember PQ based on the diagram, we can go P to O, O to Q. It looks like this, P to O to Q. Don't really need to use the diagram. You know that, right? P, O, O, Q. We call it a triangular law for addition of vector, P to O, O to Q. So PO is negative OP. You can write in any form. The question actually didn't say that you write in IJ form or column vector. So I'm just going to write in column vector, so it's easier. Then the final answer I can convert to IJ. So PO is negative OP. When they give us in coordinate, remember, coordinate of 4H to H is basically your OP. This is your OP. But you need to put a negative in front, put a 4H on top, 2H below. Your OQ will be 0, negative H. Yeah, just convert coordinate form to column vector. So this negative I can times inside, so it's minus 4H, minus 2H, minus 1H is minus 3H. So that's your PQ, right, in terms of H. But you can also write in this form, guys. It's okay to leave it in this form, column vector form, or IJ form, unless the question say give your answer in IJ form. They didn't mention you can write in any form. Okay, so I write both for you. Now next, they say that PQ is a unit vector. Find H. Okay, remember what is a unit vector? Unit vector is a vector. When you divide by its own magnitude, you get how many unit? 1 unit. Unit vector is always 1 unit. For example, classic example, just to help you understand. Let's say this is 4i plus 3j. The magnitude of 3 and 4 is 5. So this length is 5 units. When you subdivide into 5 parts, each part will be 1 unit. That's why if you get 4i plus 3j, you divide by 5, this value has a magnitude of 1 unit, right? It's only 1 unit. So I'm just going to use my magnitude of this vector PQ, right? Magnitude of vector PQ, I let it be 1. So let's take negative 4h and I square it, followed by negative 3h and I square it. Put the square root over the result is 1. So 4 squared is 16, 16 plus 3 squared is 9, is 25h squared, right? Let me write nicely here, this is a bit ugly. 25h squared, square root, that gives us 1. So 5h is 1, h is 1 over 5. Sorry, I wrote here a bit ugly. Okay, so that is the value of h, right? Do you need to put plus minus? One question. Answer is no. Why? Because you can see this is on the 4h is on the right hand side. Yeah, so it's positive. 2h is above the x-axis. It's also positive. So h should be more than 0. Don't need to take the negative value, right? Now, then they say by using vector, show that PQR are collinear. Okay, how do you prove or show that a particular vectors are collinear? Okay, maybe I already know my PQ, but let me rewrite my PQ. I know my PQ in terms of h. Take 1 over 5, sub inside. We can use negative 4 times 1 over 5, followed by negative 3 times 1 over 5. So this is negative 4 over 5, negative 3 over 5. All right, that's your PQ. Okay. Then how about QR? Wait. Do you find QR? Do you find, what do you think? PR? Maybe you find PR? Actually, QR is easier. QR is easier, right? Okay, so we do QR. QR will be QO plus OR. QO will be negative of this. So it's negative of 0 minus h. Your h, remember, is 1 over 5. Your OR is minus 8, 31 over 5. Very ugly. Yeah? So let me move this up and don't have enough space. Right? This one is ugly because of the number here. So you get negative 8. Second one is 1 over 5. Minus minus a plus 1 over 5. 1 over 5 minus 31 over 5 is minus 30 over 5, which is negative 6. Okay, so I got my PQ, I got my QR. Remember, to show that they are parallel or collinear, we must let the first vector equals to a multiple of second vector. The multiple I use here is lambda. You can use other symbol, k. Yeah. So let us write down your PQ here, your QR here, factorize. Take out 1 over 5. Negative 4, negative 3. Take out 2. Negative 4, negative 3. Again, you can write an IJ form, but for me, IJ form is a bit harder because you have to write the R, you have to underline, and write the J, underline, a lot more work to be done. So I prefer column vector, unless the question asks you to write in a specific way. Question never say, right, you have to write IJ form, so I use column vector. So we can cancel them and write 1 over 5 equals 2 lambda. Your lambda is 1 over 10. So my PQ is now 1 over 10, sub inside a lambda here, 1 over 10 QR. So if I can show that PQ equals to 1 over 10 QR, that means PQ and QR are parallel, correct? But what is the difference between parallel and collinear? Yeah, we must mention since Q is a common point, Q is a common point, so therefore PQR, they are collinear. Yeah, PQ are collinear. That's all. Okay, question number 14. So diagram shows a relation of 3 sets, set A, B, C. So you're supposed to state GFX. Now look at the diagram here. GFX means which one happens first? FX happens first, followed by GX. That means it looks like this. The order looks like this. FX followed by GX. Where do you end up? You end up at set C. So look at the diagram. I'm starting from X. I end up at X squared plus 1. So what is your answer for part A? Your answer, they say state, that state no working required. Your GFX is therefore X squared plus 1. Yeah. That is your first answer. Okay, next one, B Roman 1. Determine F inverse, then find Gx. Okay, how do you find F inverse? Okay, F inverse, we know your Fx already, right? Your Fx is x minus 2. Actually, this one I can tell you the F inverse is x plus 2, everyone. Because opposite of minus 2 is plus 2, right? So it's just the opposite operation. But if you want to show the full working, it looks like this. We let whatever that you're finding becomes y. Now, again, I want to tell you this because your textbook uses fx equals to y. I use F inverse equals to y. For me, it's easier, especially when it comes to finding specific value like F inverse 5. It's easier if you use this. Okay, but if you want, you can use your Fx equals y, the textbook method. So then we switch the position, Fy equals to x. For the textbook method, we can submit side. Now, okay, let me finish this first. This Fx is y x minus 2. Fy is y minus 2. Bring over, make y as a subject, which is x plus 2. Therefore, your F inverse x is x plus 2. If you're using this method, we write Fx as x minus 2. You make x as a subject, right? Remember, Fx is y. Therefore, F inverse y is now x. Your F inverse y is now y plus 2. F inverse x is now x plus 2. Okay, I found my F inverse, yeah? Okay, next, how do you find Gx? Well, if you want to find Gx from this GF, right? So you got to use this idea. The idea is this. If you put F and F inverse together, you will get X. Because F inverse simply means I'm going backwards. Then Fx means I'm going forward. Where do you end up? You end up at the same place where you started, which is X. So starting from this one here, I'm going to put, okay, let me use a bit more space over here. I'm going to put F inverse inside my Gx. If you put F inverse inside my Gx, I must put F inverse inside here. All right. Now, I know some people use substitution, but because the question mentioned hence, hence means you have to use the result. Use your F inverse to do it. And we can cancel these two. You're left with Gx. What's my F inverse? I've already got my F inverse, which is what? X plus 2. I square it and then I plus 1. Okay, can you simplify further? Yes, we can expand and simplify. This will be x squared plus 4x plus 4 plus 1. Answer x squared plus 4x plus 5. All right. Okay, the next part, we're going to sketch a graph. The graph of y equals gx is already given. You're supposed to sketch G inverse. Okay, this is your y equals gx. The relationship between the function as inverse is given by what? The reflection in the line y equals x. So sketch your y equals x. If this is 0p, when you flip it over, reflect over, this one becomes p0. You draw a curve like this. It looks like a reflection. That will do. Your y equals g inverse will be this. Okay? Right, let me pause for a while. Okay, for part C, you're supposed to use the result, your information here. Your fx is what? Your fx is x minus 2, right? You're supposed to find f2x, f3x, f4x, and then hence state f75x. Okay, we know fx is x minus 2, correct? We're supposed to find f2x, okay? f2x means fx. That is, we put x minus 2 inside x minus 2. So there's a bracket minus 2 here. What do you put? X minus 2 inside. You get x minus 4. Then let's do f3x. f3x is x. Okay, let me write f2x. That is, I'm putting x minus 4. f2x is x minus 4 inside your fx. So fx is bracket minus 2. There's a minus 4 here. This becomes minus 6. Let's do f4x. I can do f3x. You can even do f3f, doesn't matter. So f3 is x minus 6. Sub inside, you get x minus 6 minus 2. That gives us x minus 8. So there is a pattern here you can see, right? That is your fx is x minus 2. Your f2x is x minus 4. 4 is 2 times 2. Maybe I can put 2 times 1 here. Your f3x is x minus 2 times 3, right? This is like your mod maths, right? Mathematical, logical reasoning. We call it what? Making conclusion by induction. So we can say fnx is x minus 2n. And if you want to find f75x, you take x minus 2 times 75. 75 times 2 is what? 150. So a bit long, I got to list out. Okay. Okay, this is quadratic function from 4 chapter 2. Given that the sum of area of the shape is more than 8, using table method, find the range of values of x. Okay, so number one, we know this is a square. They say it shows a square and rectangle. Square is x times x, which is x squared. Rectangle, we can take length times breadth, or x times 2x plus 10. The sum is greater than 8. So let's simplify further. This is x squared plus 2x squared plus 10x greater than 8. So 3x squared plus 10x minus 8 more than 0. Before we solve using table method, we should factorize first. 3 times 8 is 24. What's the factor? I should use 12 and 2 plus and minus to get 10. Right? The roots are 2 over 3. Wait, let me just simplify right nicely. 2 over 3 and negative 4. Okay, so remember table method. Now, for me, the table method is rather ridiculous because we already know the answer. We're going to show the working, right? So it works like this. You need to start off by writing, this is your first bracket, 3x minus 2. Second bracket, x plus 4. Okay, sorry, I need more space for this because I need to put a third bracket. The third bracket, no space. My first bracket is 3x minus 2. Second bracket is x plus 4. Third bracket is these two multiply together. All right. Now, then we know the roots are 2 over 3 minus 4. Minus 4 is smaller, so you divide it into 3 sections. The first one is x less than negative 4. Second one, x between negative 4 and 2 over 3. Third one, x is more than 2 over 3. It's like we draw the graph. Remember the graph? Most people are more familiar with the graph, right? So the graph looks like this, right? So we already know the region. Right? This is less than negative 4. This is in between negative 4 and 2. This is more than 2 or 3, right? So we know the shape looks like this. The answer more or less we know, but we need to represent it in the form of table. Okay, the table method works like this. You need to sub in. Sorry, let me draw this nicely. Wow, still not very nice. Let me just draw my line straighter. Yes. Okay. So you need to take a value less than negative 4. Okay. And we sub inside this 3x minus 2. So you can use your calculator or mentally if you want. 3 alpha x minus 2. Pick a number less than negative 4. Pick a number less than negative 4. That would be negative 5. I put negative 5 inside. I got negative 17. So most important thing is the sign. It's negative, right? So we put negative here, right? Up to you. You can, some people, or you don't want to put the bracket, so never mind. I just put a negative, right? Then pick a number between negative 4 and 2 or 3. The easiest number to put in is what? 0. Put 0 inside. You should get negative number. So this negative, this is also negative. Pick a number more than 2 or 3. The easiest number to put in is 1. You get 1, which is positive. Yeah, remember the sign that I'm interested. I'm not interested in the value. You don't have to go and put a 1 inside. We just show it's positive or negative. Then we move on to x plus 4. Change this to plus 4. Get the 3. Pick a number. Yeah, actually, you don't have to count like this one. You can just use mental arithmetic. Just use brain to count, right? You don't need to put in. But just want to show you, put in negative 5. This is negative. So, right? First one is negative. Second one, put a number between negative 4 and 2 or 3. The easiest number is 0. You get positive 4, which is plus. Bigger number more than 2 or 3, let's say 1, or you can put 2 also, doesn't matter, positive 5. Okay, remember, the idea is this, we got two numbers multiplied together. If I give you a positive number times a positive number, answer is positive. A positive times negative is negative. Negative times positive is negative. Negative times negative is positive. So you're using the concept of multiplication of two numbers, right? So the first number here is negative. Here, you multiply with negative. Your outcome should be what? Your outcome should be positive. Then the second one, negative times positive. Negative times positive should be negative, right? Hello? And you can put a bracket here if you want to highlight this. Positive times positive is positive. So what we want? We want this to be more than 0. We want it to be positive, right? So which region is positive? Here and here. So we need to take this answer, and this answer. That's why we know our answer is x less than -4 or x more than 2/3. Okay, let's look at part B. So a quadratic equation is given by this, where P is a constant. Find the range of values of P if the equation has imaginary root. Imaginary root means no real root. So first we bring this over. Your x squared plus 3x plus 4p is now 0. Let's do b squared minus 4ac. Remember, if it has imaginary root, your b squared minus 4ac, your discriminant is always less than 0. Your b is 3, you square it. Your a is 1. Your c is 4p, the result is less than 0. This is 9 minus 16p less than 0. You can bring the 9 over, becomes negative 9, right? Negative 9. 9 divided by 16, both are negative, cancel each other out. Change the symbol. Whenever it times and divide with negative, the symbol has to change. So p is greater than 9/16. Okay, that's Roman 1. Roman 2. It is given that equation has roots of alpha and beta. Form a quadratic equation with the roots of alpha minus beta plus 1, beta minus alpha plus 1. Okay, so what do you do? Let's find out your SOR POR. Remember SOR POR? Alpha plus beta minus B over A. POR is what? Alpha times beta, C over A. So based on this equation here, my sum of roots alpha plus beta is negative b, b is 3, a is 1. So I'll write the over 1 because nowadays they're very picky. They say you don't use a formula, so you rather write the over 1 here. Your POR, alpha times beta, C over A, which is 4P. Now, I need to find my new SOR. Your new base SOR is based on these two roots, which is alpha minus beta plus 1 and beta minus alpha plus 1. Now, notice that your alpha and alpha can cancel out. Your beta and beta you can add up. Can also cancel out, right? Hey, both your alpha beta can also cancel out, right? Isn't it? Let me highlight for you. One is negative, the other is positive. You add them together, what do you get? You get 0, right? Hello? So what is your SOR? Your SOR is just 2, right? Then you look at your new POR. Okay, your new POR a bit interesting. So because a lot of people will have trouble trying to expand this bracket. Okay, I will do it a little bit differently. Everybody, I'll do it a bit differently. You see, this is alpha minus beta, this beta minus alpha. So what I do is, we know A, for example, B minus A, when you take out negative, becomes what? A plus B, right? Hello? Are you with me now? Yeah? So, and I'm going to put this at the back. I'm going to put this at the back. 1 plus alpha minus beta. This one, I'm going to take out the negative. I put a 1 in front. I take out the negative. Beta minus alpha is going to be negative alpha minus beta. Because I find it's easier to expand like this. I say this again. Beta minus alpha, when you take out the negative, it becomes alpha minus beta. Okay? So the reason why I do that, because I want to use this concept. A plus B multiply with A minus B When you expand, you get a square minus b square. So this will be 1 square, which is 1, minus alpha minus beta square. It's easier this way. Yeah. Otherwise, you got to expand 1, 2, 3, 4, 5, 6, 7. That, yeah. Imagine you try to expand this. How many terms you should have? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 terms here. Yeah. So I don't want to do that. I use this method, but you must be able to see that you got to factorize first. Okay. Now with that, this is 1 minus alpha square minus 2 alpha beta plus beta square. The negative you times inside 1 minus alpha square plus 2 alpha beta minus beta square. Or should I expand first? Let me think. Should I expand first? Wait, hang on. Should I expand first or should I? I think I better use this first. Don't expand first. Okay. You know why not? Because I need to use this result. Everybody, I need to use this result. This one. And this result. So I must say this question a bit harder. I need to relate them. Now, how do you do that? Okay. We know that everybody, a plus b squared, or I use a different color over here, no space. A plus b squared, right, everyone? A plus b squared, or maybe I write alpha plus beta square. If you take this, you square it, you should get what? Alpha square plus 2 alpha beta plus beta square. If I only want my alpha square plus beta square, everybody, I should bring this figure to the left. I'll get alpha plus beta square minus 2 alpha beta. Are you with me or not? Hello? Are you with me on this? Yes? Okay, so I'm going to use that now. This alpha square plus beta square, which represent these two here, I'm going to use alpha plus beta square minus 2 alpha beta, but there is another minus 2 alpha beta at the back. So that gives me 1 minus alpha plus beta bracket square minus 4 alpha beta. Yeah, I must say this question a bit harder, right? Why do I express in terms of alpha plus beta? Because I have my alpha plus beta over here, this one. This is my alpha plus beta. I have my alpha beta over here. So I need to take these two and sub inside. Your alpha plus beta is negative 3. Your alpha beta is 4p, correct? There's another bracket outside, so it's a 9 here. 1 minus 9 minus 16p. Expand, you will get 16p minus 8. Positive 16p, yeah? Yeah, 16p minus 8. Okay, we're not done yet. We've done all this to do one thing. Form the equation. What's the formula to form the equation? X squared minus new SOR. My new SOR is this. And new POR is this. So the formula is always minus new SOR, which is 2. Maybe I just write 2 straight away. Followed by X. And new POR, 16p minus 8. The result is equal 0. Yeah, guys, I hope you learned something from this discussion. Yep. I hope to see you guys in our next video. Thank you.